Why do large Python strings use so much memory? Imagine working with a huge piece of text in Python and suddenly noticing your program slowing down or using a lot of memory. That's because large strings in Python can take up a lot of space. But why is that? Let's find out. Python stores each string as an immutable object, which means once created, it cannot be changed. Because of this, Python keeps strings in a special area of memory called the heap. When you create a big string, Python allocates a large block of memory to hold all the characters. This block is stored in contiguous memory, meaning all the characters are lined up one after another. The more characters you add, the more memory Python needs to allocate. Now, Python strings are Unicode, which means they can include characters from many languages and symbols. To support this, Python uses different internal encodings. If your string contains only simple Latin characters, it uses 1 byte per character. But if it has special characters or symbols, it might need 2 or even 4 bytes per character. This means a large string with complex characters can use much more memory than one with plain English letters. Each string object also carries some extra information. Besides the actual characters, Python stores the length of the string, a hash value used for quick lookups, encoding details, and other internal data. This overhead can be around 50 to 80 bytes per string. For small strings, this overhead is a big part of the total memory, but for large strings, the character data dominates. Python also tries to save memory by reusing strings that are exactly the same. This process is called string interning. It works well for small or common strings, but it doesn't help much with large, unique strings. Each large string still takes up its own memory space. When you manipulate large strings, like slicing or concatenating, Python often creates new string objects and copies data into them. This copying process temporarily increases memory use. Also, Python's memory allocator adds some padding and extra data around memory blocks to prevent errors, which adds a little more to the total memory footprint. In automation and scripting, you often work with large text files, logs, or reports. Knowing why large strings use so much memory helps you write better code. For example, instead of repeatedly concatenating strings, you can join a list of smaller strings, which is more memory efficient. Using byte arrays for binary data can also save space. Remember that slicing creates new strings, so avoid unnecessary copies when possible. To sum up, large Python strings use a lot of memory because they store each character in contiguous heap memory, often requiring multiple bytes per character for Unicode support. The extra object data and the way Python manages memory make large strings inherently memory hungry. Understanding this helps you handle text data more efficiently in your automation and scripting projects.